In this video we are going to discuss about the multipliers. On completion of this topic, students will be able to understand what is partial product generation and the 4-bit array multiplication. So multipliers are widely used in the digital signal processing. It has more than in general purpose workloads. That is, major categories of this multiplier types are unsigned. Also, it is used for the sign magnitude data. So signed 2's complement and signs 2's complement is very useful for the fixed points 2's complement data. It is typically used in the manner broadly to how we are using in the paper or a pencil. So first one is binary multiplication. So in this binary multiplication, 4-bit unsigned multiplicand, that is 8 times 4-bit multiplicand b. So b should be signed or unsigned. So you can see here an example of multiplicand and multiplier. So the product is calculated as p is equal to ax into by, that is ax and by. So first we are calculating the multiplicand with the multiplier. So it produces the output of 101010 into 1011. So the multiplicand is given to the multiplier as 101010, which produces the partial products. With the final of this four things, we will be producing the result as 11101110. And the next one is the array multiplier. So this array multiplier is a digital combinational circuit which is used for multiplying the two binary numbers by employing an array of full adders and half adders. And also it is generally used in the simultaneous addition of the various product. By checking the bits of this multiplier one at a time, it can be requiring a sequence of add and shift micro operations, which can done with one micro operation by means of the combinational circuits and produces the product bits at all time. So this is the way we can multiply the two bits, since all this takes at the time for the signals to propagate through the gates that forms the multiplication array. So to implement with the array multiplier, it is used to implement in the process of signal. So first this process, that is multiplicand bits b1 and b0, the product is finally produced at the partial products. And here the first partial product is formed by multiplying a, b and b. This multiplication of two bits produces a1 if both the inputs are 1, otherwise it is 0. So this is identical to one of the AND operation and can be implemented with the AND gate. This product is formed by means of two AND gates, and the partial product can be multiplied by the a and the b, which is shifted to one position to the left. And also the above partial products are added with the two half adders. Usually these are the two more bits in the partial products, which produces very least significant bit of the product and does not have any other adder to form in the output of the AND gate. The next one is the carry save adder. Carry save multiplier is nothing but it is the parallel multiplier for unsigned operands, and also it is composed of the two input AND gates for producing the partial products. As a series, it can be added with a ripple carry adder for producing the final output. And here the carry save adder in the VLSI is this seems to be the most useful adder for the application, and also it is a parallel ensemble of k adders without any horizontal operations. And here it contains a multiplier cell and vector merging cell, which are broadcasted through the complete array. And next one is the Wallace tree multiplier. This Wallace tree multiplier is a parallel multiplier that works on the Wallace tree algorithm to efficiently multiply two integers, and this uses the full adders and half adders to reduce the partial product tree to two rows. So this final adder can be used to add the two rows of the partial products. So here the major advantages, it has to reduced latency, which causes 44% higher speed, and power consumption is only 11%. So this can be reduced to the first stage, second stage and the final stage. And if you give the main thing, this higher speed and the lower consumption can appear in the reduced silicon data. So here you can see the types, that is partial products, first stage, second stage and final adder. So first if we are giving the half adder, then it produces the partial output, so finally it is added in the result. And here you can see the Velocity multiplier operation, and the multiplier significantly it has to identify the critical parts, and also it has the possible techniques: data encoding, logarithmetic, and pipelining. Questions: how carry say multiplier differs from array multiplier? Thank you.